Let's start by reading the question. A record was kept of the different types of vehicles caught speeding by a speed camera. An analysis revealed that for those vehicles caught speeding by the camera, the percentage of each type of vehicle was shown in the table. This table, as you can see, is at the bottom of the question. A random sample of 30 vehicles was caught speeding by the camera is selected. Then we're asked to determine some probabilities. For part I, we are asked to determine the probability that the sample contains exactly 3 vans. Let's start by thinking about our distribution. It's a binomial distribution, n is 30 and p is vans, so 0.25 from the table. It's asking for the probability that x equals 3. For this, we can either use the binomial formula or we can use our calculator. If I go to my menu, I go to number 7, which is distributions, and because it is asking for exactly 3, that is a precise distribution, so I'm going to use binomial PD, number 4. As I only want one number, I'm just going to go for variable, where my x value is equal to 3, my n value is equal to 30, and my p value is equal to 0.25. I can do this in the formula NCR p to the r q to the n minus r, and it should give me the same answer. 0.02685. Part 2, this time is talking about cars. So I need a new distribution that is binomial, still with a sample of 30, but this time my probability for car is 0.45. This one asks me for the probability that it is fewer than 15. Fewer than 15 means 14 or under, so I can write it like this. And I can either use the tables or I can use the cumulative function on the calculator. Menu, distribution 7, scroll down this time to binomial CD, number 1. And again I'm going to go for variable, where x is 14, n stays the same at 30, but this time I change my p to 0.45. This gives me the probability of 0.6448. Part 3, if I move up to the right hand side, this time is looking at vans or heavy goods vehicles. So if I move the calculator to the other side, just for the moment, I have my distribution that is still 30, but my probability now needs to be vans or heavy goods. So 0.25 and 0.15 make 0.4 or 0.40. The question is asking for at least 10, so the probability Z is greater than or equal to 10, and as I can't do greater than or equal to, I need to do 1 minus what I don't want, which is less than or equal to 9. So again, either in the tables or on the calculator, I need to go menu, distribution 7, scroll down to binomial CD, 1, and for variable, my x will be 9, my n stays still at 30, and this time my p is the combination of 0.25 and 0.15, so 0.4, which means I have 0.17628. 0.86. And that's the bit I don't want, so I will minus that to give me 0.823714. The final part of this question, part B, is these in-betweeny probabilities. Part 4. It asks for, still sticking with this binomial distribution, I've run out of letters, I'm going to have to go back round to A. And I've still got 30 vehicles. And this time it is not motorbikes. So motorbikes is 0.15, so not motorbikes is 0.85. This asks me for a probability that it is more than 20, but at most 25. So I need to do that it is less than or equal to 25, take away the bits I don't want, which is less than or equal to 20. So again, on my calculator, menu, distribution 7, scroll down to binomial CD, and this time I'm going to go for the list option so I can get my two values of 25 and 20 at the same time. What are you doing, miss? My N is staying at 30. This time my P for not motorbikes is 0.85. And that gives me my two probabilities, 0.4755, take away 0.0096, taking it out of standard form. And then to work out that subtraction accurately, I'm going to go back onto menu and up to calculate, number 1. And I'm going to put that in, 0.4755 minus 0.0096. And that gives me my answer, turn it into a decimal, of 0.46